Alright, welcome back. Today, we're going to talk about 7.5. Hopefully, I see a lot of you guys taking quizzes and getting this stuff done, and some of you are starting to move ahead, so I'm trying to stay on top of these videos for you to keep you moving ahead. This is our last week before the test, so our test is next week. It's next Tuesday. We got to be ready for that. We got two quizzes this week. One is over 7.3, 7.4, and we got a quiz over this 7.5 on block day. So start numbering it all together. Okay, here we go. So 7.5 is all about rational exponents and radicals. All right. This is an index. Okay, so this is my normal radical symbol, okay, but we have an index, a number in here quite often. If we say square root, which is often what you hear with this, it's a 2 that's in here, but we don't ever write the 2 because that's implied. But if it's a cube root or a fifth root or something like that, we have to write the number in there. The number underneath is called the radicand. Again, you may or may not know that, but just whatever's underneath the radical is called the radicand. And we can write radicals two different ways. One, we can write them as rational exponents. Okay, so the square root of a to the m is the same as a to the m over 2. The square root, again, remember I said that that's going to be 2. All right. So these are just saying, hey, these are all logically equivalent. They're all the same thing, just however you see them. And I'm going to have you writing them back and forth in different ways. You just need to know what they mean. All right. And these last two right here tell me it doesn't matter if I take a to the m first or if I take the root of a and then take it to the m power. It doesn't matter. Okay. And we'll talk more about that as we go through this. Number one. Let's talk about number one. Number one. If I want to simplify this, cube root, so 3 is the index, 27 is the radicand. My radical symbol, if I had a power over here, would be 1. All right. The cube root of 27 is asking you what number do you multiply times itself twice, or what number do you use 3 times with multiplication to get to 27, and it's 3. 3 times 3 times 3 equals 27. Therefore, the answer is 3. Okay, just like when we square root. Square root of 16 is 4. Why? Because 4 times 4 is 16. Now we're talking about cube roots. This is a 17th root, so it's asking you what 17 numbers am I going to multiply together that are all the same, that are going to give me 0. This is pretty simple. It's 0. This one's the 5th root, so I need to find a number that I'm going to multiply together 4 times, a total of 5 numbers. That's going to give me 32. So I'm going to start with the easiest one, 2, 2, 2, 2. There's 1, 2, 3, 4, 5. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Oh, nice. Got it on the first try. So that answer is 2. All right. Let's go on to the next page. All right. All I want you to do is going from this right here, I just want you to rewrite every single one of these radicals in exponential form, and then I want you to rewrite every one of these radicals in exponential form, and rewrite every one of these exponential forms in radicals. I just want you to flip it to the other way. You're using this right here, okay? Using this right here. If you see it like this, I want you to rewrite it like this. If you see it like this, I want you to rewrite it like this. Alright? Hit pause, do that now, and then we'll come back together and work through them. Alright, hopefully you got through these without much trouble. Again, all we're doing is switching forms. So I see a 2 in the denominator, so that's the square root of x to the first. Okay? Again, we don't have to write the 1 or the 2, but right now let's just write everything. It's not wrong if you do. This one's a little tricky. W is the base of 4/3, so it should be 12 times the third root of w to the 4th. Okay? Got to be careful of that. Now this one takes the whole thing, so it is the 4th root of 16z. And because I'm multiplying this whole thing, or this whole thing is being taken to the 5th root, I'm going to go ahead and put the whole thing in to the 5th power, like that. It's just easier when you have multiple numbers down there that you need to distribute that exponent to. Alright, now going the other way. A to the, this is always easy. This seems a lot easier. A to the 7/4. Oh, this one's tricky. Be careful here. 36 to the 1/2. Again, remember, if there's nothing here, there's always a 2. If there's nothing here for a power, there's always a 1. And x to the 6/2, which reduces 36 to the 1/2, x to the 3rd. Okay, tricky one. Be careful of that thing. Now this one just going the other way. So 16w, I'm going to put it in parentheses, to the 3/6, or 16w to the 1/2. Reduce, 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 reduce. Oh, parentheses. Alright. Hopefully that went pretty well for you, or you're starting to pick it up. Let's try to simplify. Okay, so we're going to try to simplify and then write in radical form. Alright? Remember, if you're multiplying bases, what do you do to the exponent? Multiplying similar bases, what do I do to the exponent? Hit pause now. Give it a try. Alright, so on this one, hopefully you figured out this is x to the 2/3. This is x to the 1/4. Sorry for writing it that way. I hate the way that this thing writes it, but that's alright. We'll work with it. So if we multiply like bases, I have x's on both sides. We have to add exponents. When you add fractions, you have to find a like denominator. So 12 is the like denominator, which means here, what did I have to multiply 3 to get 12? 4. So 4 times 2 is 8. Here, what did I have to multiply times 4 to get 12? 3. So 3 times 1. So this is x to the 11/12, which means, make my big radical, 12x 11. Done. This one's a little tricky. X to the 2/3, and then 8 to the 1/3, and x to the 1/3. So that 8 to the 1/3, I'm just going to pull that thing right out of there. That's the cube root of 8. Keep him right there. These other two right here, x to the 2/3 plus 1/3. Well, that's 3/3. I already have like denominators. So that's just x to the first power. So x to the first power. I'm going to write out here in front and make sure it does not end up underneath the radical. It should not. Okay, equals 3/3 equals 1. Done. Last page. Alright. Simplify and write in radical form. Remember, we have to have like powers to add or subtract. The bases have to be the same and the powers have to be the same. You look for a little bit more in the adding and subtracting, so you got to be careful. Be cautious. Alright? So this would be 4a to the 7/5 minus 6a to the 7/5, and these are similar. That works out nicely. So minus, excuse me, minus 2a to the 7/5. There's my answer right there. All right, 14. Do this one last. That one's pretty easy. Here we go. X to the 6/3 minus 3. Okay, be careful again. What's in here? If there's nothing in there, should always be a 2. 4 divided by 2. So this actually does turn out pretty nicely. X squared minus 3x squared. So negative 2x squared. And that's called booyah. This video is running a little long, so I'm going to go ahead and shut it down. Make sure you answer the quiz at the bottom of the page. And I will see you on Tuesday.